Welcome to my presentation. In this presentation, we shall look at some examples related to cross products and vectors in three dimension. So let us take an example. If A is a vector and if the components of these are 3i minus j plus 2k, and if B is another vector and if the components of these are 2i plus j minus k, and if C is another vector and if the components of these are I minus 2j plus 2k, then we want to show that one of the properties of cross products is true, and this time we want to show that vector A cross vector B plus vector C within parentheses like that is the same as vector A cross vector B plus vector A cross vector C. So here again we will call this as the left hand side of the equation, and then we'll call this as the right hand side of the equation, and then we will take left hand side and we will come up with an answer. We'll take the right hand side, we'll come up with an answer. We'll compare those two, and if those two answers are exactly the same, then this property is true. So let us get started. So we'll start with the left hand side. We'll start with the left hand side of the equation. In here, the way we want to write this one out is as follows. Vector A is given to us as 3i minus j plus 2k, right? And then this is cross, and inside the parenthesis we have vector B, which is 2i plus j minus k, and then vector C is plus I minus 2j plus 2k, isn't it? So when we simplify this, this is going to be 3i minus j plus 2k, and we want to cross that with 2i plus 1i is 3i, j minus 2j is minus j, minus k plus 2k is plus k. So we've simplified that. We've combined similar looking terms. Now that we have this information, we're going to use determinants to simplify this cross product I, j, k, and we're going to pick the coefficients of I, j, and k for the first vector and for the second vector. For the first vector we have 3 as the coefficient of I, the coefficient of j is -1, the coefficient of k is 2. In the second vector, the coefficient of I is 3, the coefficient of j is -1, and the coefficient of k is 1. So if we find the determinant of this, we have found the value of vector A cross B plus C. So therefore, when we expand this, it is going to look like this. I, the minor of that. So here again, I want to say that we're going to travel along the first row, and the sign convention we're going to use is positive, negative, positive. Okay, so having said that, we're going to expand this. I, the minor of that is going to be, let me write this, let me be consistent here. I, the minor of that is -1, 2, -1, 1, and then minus j, the minor of that, which is going to be 3, 2, 3, 1, and then plus k, the minor of that, which is going to be 3, -1, 3, -1. So we got all the components in there, and now it is just a matter of simplifying this. This is going to be equal to I, -1 times 1 is -1, -1 times 2 is -2, times negative will be +2, minus j times 3 times 1 is 3, minus 3 times 2 is 6, plus k times 3 times negative 1 is negative 3. This is k. Let me write that, clean it up. Plus k. 3 times negative 1 is negative 3, minus 3 times negative 1 is negative 3, minus will be positive 3. So therefore, we can come back and then simplify this as 2 minus 1 is 1, so therefore 1i or just I. 3 minus 6 is negative 3. Negative 3 times negative, it will be positive 3j. And then 3 minus 3 is 0, so therefore 0k. I just want to put that in there. Therefore, the value of vector A cross vector B plus vector C is this value here. I'm going to put this in a box here. This is what we've arrived at. We will now take the right hand side and see if we can come up with the same answer. On the right hand side of the expression is given to us as this: vector A cross vector B plus vector A cross vector C, like that, right? Therefore, in here we know the components of vector A, we know the components of vector B, and we know the components of vector C. Therefore, we can write that as follows: A cross B I can write as I, J, K. The coefficients of I in the vector A is 3. The coefficient for J is negative 1. The coefficient of K is 2. For vector B, the coefficient of I is 2. The coefficient of J is 1. The coefficient of K is negative 1. So we want to find the determinant of that. Then we'll come back and then add it to A, vector A cross vector C. Vector A, let me write this: I, J, K. Vector A, the coefficient of I is 3, the coefficient of J is negative 1, the coefficient of K is 2, and for C, the coefficient of I is 1, the coefficient of J is negative 2, the coefficient of K is positive 2. If we find the determinant of that, when we add the values of these two determinants, we should get a value, and we will see what that value is going to be. So in here again, we will travel along the first row, and the sign convention we're going to follow is positive, negative, positive. Same thing here, we'll travel along the first row, the sign convention will be positive, negative, positive. Therefore, when we expand this, we're going to have I, the minor of that will be negative 1, 2, 1, negative 1, minus J, the minor of that, which is 3, 2, 2, negative 1, and then plus K, the minor of that, which is 3, negative 1, 2, 1, and then plus all of that. I, the minor of that will be negative 1, 2, negative 2, 2, plus or minus J, the minor of that will be 3, 2, 1, 2, and then plus K, the minor of that will be 3, negative 1, 1, negative 2. So if we expand this, we should be able to get an answer. So let us expand this. This is going to be I times, this is negative 1 times negative 1 is positive 1, minus 1 times 2 is 2, minus J times 3 times negative 1 is negative 3, and then minus 2 times 2 is 4. Okay, then plus K times 3 times 1 is 3, 2 times negative 1 is negative 2, that will be positive 2. Then in here we have plus I times negative 1 times 2 is negative 2, then minus 2 times 2 is 4, like that, minus J times 3 times 2 is 6, minus 1 times 2 is 2, plus K times 3 times negative 2 is negative 6, then 1 times negative 1 is negative 1, times negative will be positive 1. So therefore when we simplify this, this is going to be 1 minus 1 minus 2 will be negative 1, negative I, negative 3 plus negative 4 is negative 7, negative times negative is a positive, therefore 7j, 3 plus 2 is 5, therefore 5k. And then here we have 4 minus 2 is 2, plus 2i, 6 minus 2 is 4 with a negative sign, therefore negative 4j, and then negative 6 plus 1 is negative 5, negative 5k. So we'll combine all the i's and j's and k's and see what we get. So when we combine this, we get 2i minus I, 2i minus I is 1i, or just I, and then 7j minus 4j will be equal to plus 3j, then 5k minus 5k, that will be equal to 0k. Therefore, this is the result of vector A cross vector B plus vector A cross vector C, isn't it? I'm going to put a box around that just to indicate what we have arrived at. Therefore, if you look at this and if you look at the value what we've got here, this value and this value is exactly the same. This value and this value is exactly the same, and therefore we can come back here and then state that vector A cross vector B plus vector C within parentheses is equal to vector A cross vector B plus vector A cross vector C. Therefore, the left hand side is exactly equal to the right hand side, and therefore this property is true for the cross product using determinants. Determinants gives us a very powerful way of solving some of these vectors in 3 dimensions. In my next presentation, we shall look at some more examples related to cross product using determinants and using vectors in 3 dimensions.